I recently tried to organize a dinner party seating chart by just, drawing names from a hat.
Oh, no.
Yeah, I figured random chance would make for an interesting dynamic, but instead I just ended up with two X's at the exact same table.
Let me guess. Total chaos.
Absolute chaos. There was this wildly heated debate over the appetizers, and as it turns out, relying on randomness is just a highly inefficient way to construct a stable system.
Which is a very familiar headache for anyone who follows graph theory. For decades, mathematicians relied heavily on the probabilistic method. Basically, you throw elements to random chance.
You just hope it works out.
Right, you hope the probabilities align to prove the existence of specific, highly structured mathematical objects, like Ramanujan graphs.
Which brings us to our mission for today's deep dive into the source material. We are looking at the Marcus Spielman Srivastava, or MSS, Interlacing Polynomials method.
It is such a profoundly optimistic look at human problem solving.
It really is, because we're exploring how MSS used this technique to finally crack the Kadison-Singer problem, which is this massive mathematical mystery that sat completely unsolved from 1959 all the way until 2013.
The historical hurdle here was that researchers were constantly wrestling with random matrices to find these structures. And it is notoriously difficult, well, almost impossible to control the maximum eigenvalues of a sum of random matrices when you are just at the mercy of probability.
But wait, translating a 50-year-old matrix problem into polynomials could not have been an obvious move. I mean, why polynomials? What makes them so much easier to manipulate than the matrices themselves?
It really comes down to the characteristic polynomial. MSS realized that if you look at the expected characteristic polynomial of a sum of random rank 1 matrices, it actually has real roots.
Oh, wow.
Yeah, so by shifting to polynomials, they discovered they could effectively bound those roots, which in turn allowed them to bound the eigenvalues of the matrices. It completely bypasses the unpredictability of the probabilistic method.
It's a brilliant way to uncover the right path without relying on luck. And speaking of uncovering where agents could make the most impact, whether for your business or personal life, we should mention our sponsor, Embersilk.
Oh, absolutely.
If you need help with AI training or automation or integration or software development, you can check out embersilk.com for your AI needs.
So shifting back to the mechanics of interlacing families, before we get to the broader tree of possibilities, we should probably define what interlacing actually means in this context.
Right, we're talking about the roots of one polynomial alternating with the roots of another along the number line, right?
Precisely. If you plot them out, the roots of polynomial A sit strictly between the roots of polynomial B. MSS built this vast mathematical tree representing all the possible choices of these matrices.
And by averaging the polynomials at each branch, they proved that their roots interlace.
Exactly. Because of this shared interlacing property, the largest root of a parent node in the tree is strictly bounded by the maximum root of its children.
So rather than testing every single possibility, you mathematically guarantee a bounded outcome. It's like looking at a massive branching maze and mathematically guaranteeing that at least one single path leads exactly to the treasure without having to test every single branch.
That is a highly accurate way to visualize it. The method guarantees that at least one path down that tree of possibilities yields the exact bounded eigenvalues you need to solve Kadison-Singer.
It really highlights our capacity to conquer seemingly insurmountable hurdles just by inventing a new analytical lens.
Yeah, the solutions often exist right there. They just require a translation into a different language. It's incredibly inspiring.
That is a fascinating takeaway, and I want to leave you, the listener, with a final thought to ponder today. What stubborn, impossible problem in your own life might suddenly become solvable if you just translated it into a completely different framework, much like MSS did with matrices and polynomials?
It is definitely something worth thinking about.
It really is. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.